NGSS nerd. I am really excited today to share with you one of my favorite next generation performance expectations. This expectation that we're going to focus on today is 5-LS1-1, and it says, support an argument that plants get the materials they need for growth, chiefly from air and water. The clarification statement says, emphasis is on the idea that plant matter comes mostly from air and water and not from the soil. When I thought about this performance expectation and supporting an argument for these things, I thought that it would be very powerful for the students to do their own experiment and use the evidence from their experiment to support the argument. So today we're going to set up an experiment with 5 plants. For the first plant, it's going to get all of the resources needed for growth. Each of the other plants are going to be missing just one resource. So we'll take away the water, or the next plant will take away the sunlight, the next plant no carbon dioxide, and the last plant will take away the soil. And then students will observe these plants over the course of a couple of weeks to see which plants survive and which do not. Let's get started. Let's take a look at the materials you'll need to do this experiment. First, you will need 5 plants that are about the same size as each other. I bought these ones from Home Depot, and they're already separated into 6 containers. This one is a little taller and skinnier and a little more yellow than the others, so I'm going to leave this one out and I'll use the other 5. If it's the middle of winter or sometime when it's difficult to get plants, you could also start growing your own from seeds inside under a grow light and use those. Next, I'll need Post-it notes or labels for each plant. The next set of materials I will need to take the carbon dioxide away from the plants and seal it from getting any new air. My original plan was to use a pop bottle and cut the top off, put the plant inside, and then use the packing tape to tape around and make sure it has a nice seal. But my husband was super helpful and recycled the pop bottle I saved. So instead I'm going to use this mason jar. Anything that has a complete seal will work. Next, we need containers for the plant without any soil. And what I do is, after you take the soil off of it, it'll need something to be propped up on in a container of water. So I just take a smaller container, flip it upside down, and put it into a larger one. So here, there's 2 different size beakers, and I just take the small one and put it upside down in there to prop the plant up on. You could also do this with other containers that you have at home. Here I have 2 different size mason jars that would also work. Next is a shoebox. This one will be to take away the light from the plant. If you have little sections where you can see light's gonna get in, we'll need to tape those shut and seal them off to make sure it's a total and complete seal and that no sunlight will get in. And lastly, for when the experiment starts and students start observing, you'll need rulers for each group. And you'll need some sort of container to measure how much water you're giving to each plant so that you're giving each plant consistent amounts of water each day. Now let's set up each plant to get ready for the experiment. I cut my plants into individual sections so that I could still use the plastic container as the main container to hold the plant. The first one is very easy. All you need to do is put the container onto a plate so that when you water it, it doesn't go all over your counter. And this is plant 1, and it's going to get all of the resources. We're not going to take anything away from it. The second one is also easy. This is our no water. So we don't need to do anything to it. Just from this point on, we are not going to water it at all. Next, we're going to set up the plant that gets no carbon dioxide. I did end up finding a plastic container. This is an orange juice bottle that I cut the top off of. And I'm going to put the plant inside. And then I am just going to fill the bottom with water so that this plant still does get water as well. Even though we're shutting it, all this water will stay inside. Then I'll put the top over it, and I will take my tape and put tape around the outside of the container. You may want to put a couple layers just to make sure that your seal is complete and that you're pushing it down all the way as you go up. Now let's prepare the plant that doesn't have any soil. What you'll need to do is gently take the plant out of the container. And you'll start by shaking and breaking off as much of the dirt as you can by hand first. This has a lot of roots inside, so it's gonna take me a little time to get the soil all loose and to shake it out. Once you get as much of the soil out as you can by hand and by pulling on the roots, you'll then take it to the sink and spray out the rest of the dirt that's in here. Now, using my larger beaker with the smaller beaker on top, I'm going to put my plant without soil into here and prop it up onto that smaller container inside. I'm going to push the roots down around the outside of that container to get it to stand. And then once I have my plant in here, I am going to fill my container with water so that it still has access to the water and the roots have water. They just do not have the soil that goes with it. Lastly, I need to set up my plant that gets no sunlight. All I need to do is get the box that I use, put the plant inside, and shut the box. Now, I can tell already that this has an opening here, so I'm just going to take some tape that's easy to peel off, like masking tape, and close this so that each time we need to observe our plant, it won't be as difficult to peel off as the packing tape. Just going to put this on one section at the top and one section at the bottom to make sure that it is shut. Now you're ready to start your experiment. Students should take initial observations about the height of each plant and also qualitative observations about the health of the plant. Throughout the week, you should be watering plant number 1 that gets all resources and plant number 5 that gets no sunlight. You won't give plant number 2 because that's the no water. You won't open the container for number 3 to give it water because it is sealed and you'll let carbon dioxide in. It should have enough water in the bottom of its container. And you should check on plant 4 that its roots are down in the water. If that water starts to evaporate, add more water to the container. After about a week, students again should observe the plants, writing down the new height and new qualitative observations. One more week goes by and you'll do that one final time. At this point, the plant that gets all resources should look the best. The plant with no water will actually probably be shorter than it was at the beginning because it will be shriveled up. The plant with no carbon dioxide for my class has always started to turn kind of a yellow color and die and like start bending over. Plant with no soil has consistently lived in my classroom, which backs up the idea that plants don't actually need soil as much as they need sunlight and water. It won't grow probably as well as plant number 1 because plant number 1 gets the additional nutrients from the soil, but it doesn't need soil to live. And plant number 5 is has also in my classroom consistently died throughout the experiment, even though it has water and soil. Thank you for watching this video. I hope that you found it useful for your own classroom. If you would like additional resources for this experiment, I have student worksheets on my Teachers Pay Teachers page that include the setup for experimental design, a data table to record all of the student observations, 2 pages to help students analyze their observations, and a final activity to complete the performance expectation and create their argument about what materials plants need to survive. For more videos and free resources, please follow my Teachers Pay Teachers page and sign up for my email updates at ngssnerd.com. Thank you.